ODeL, we love.
Yes. Good morning, my fellow students. Welcome to the second uh, segment of our class. Uh, as usual, my name is Dr. Dauda Yusuf, and this is the second lesson for the course part 112, Mathematics for Public Administration. You will remember in our previous lectures, we are able to deal with the topic number systems. And so, as God will help us today, we are going to begin with another study session. This is what we call study session 2. In these study sessions, we shall be considering inequalities. Inequalities. So, by way of, we are going, in our objectives, we shall be looking at the concept of inequalities, and we are going to look at the difference between the properties of inequalities. We are going to solve inequality problems. We'll try as much as possible to apply inequalities to angle problems. So, introduction. In these study sessions or unit, as a student, you are expected to learn how to solve inequalities. A solutions of an inequalities is a number which, when substituted for the variables, makes the inequalities a true statement. Inequality is a statement that holds between two values when they are different. The notation x is equals to y means that x is not equal to y. So, and note that one is greater than the other, or even that they can be compared in size. The notations x less than y is equal, it means that x is less than y. While notation x greater than y means that x is greater than y, and that both elements are equals. Inequality is the statement that shows the relationship between two or more expressions with one of the following 5 signs. We have the less than, so we have less than or equal to, we have greater than, we have greater than or equal to, and we have equal to. So they are expressed below. X is less than y means x is less than y. X is less than or equal to y. X is greater than y. X is greater than or equal to y. X is equal to y. This is how inequality has been expressed. So, example to denote the operations of inequalities. We have 40 minus 20 is greater than 6 plus 4 is a true statement. 6 plus 10 is less than 6 minus 3 is a false statement. 3 plus 3 is equal to, is less than or equal to 9 minus 3 is a true statement. 4 plus 3 is equal to 5 minus 3 is a true statement. Minus 35 is less than minus 15 is a true statement. So find the solution set of x minus 5 greater than 12 from the replacement set 10, 15, 20, 25. You can see that we say 10 minus 5 is less than 12 is false. 15 minus 5 is greater than 12 is false. 20 minus 5 is greater than 12 is true. 20 minus 5 is greater than 12 is also true. So, properties of inequalities. Inequality has the following properties. 1, trichotomy property. If we have the trichotomy, so for any two real numbers, x and y, exactly one of the following is true. So we can say x less than y, then x is equals to y times equals to y. then x greater than y. Then we have transitive properties of inequalities. Transitive. So if x is less than y and y is less than z, then x is less than z. I think it's correct. So if x is greater than y and y is greater than z, then x is greater than z, which is also correct. So addition properties of inequalities. So let's look at the addition properties of inequality. In the addition, if x is less than y, then x plus z less than y plus z. Or if x greater than y, then x plus z greater than y plus z, which is also correct. So subtraction properties of inequalities. If x less than y, then x minus z less than y minus z. So if x greater than y, then x minus z greater than y minus z. So these properties also apply to less than or equal to and greater than or equal to. Please bear that at the back of your mind. For example, if you say if x less than or equal to y, then x plus z less than or equal to y plus z. The same apply to if x greater than or equal to y, then x plus z greater than or equal to y plus z. And if x less than or equal to y, then x minus z less than or equal to y minus z. So, solving inequalities problems. How do we solve inequalities problems? So let's look at example 1. Consider this inequality. Let's say x minus 4 greater than 5. Solution. When we substitute 10 for x, the inequalities becomes 10 minus 4 greater than 5. Thus, x equals to 10 is a solution of the inequalities. On the other hand, substituting minus 3 for x yields a false statement. That is, if you open bracket, minus 3, close the bracket, minus 4 greater than 5. Thus, x is equal to minus 3 is not a solution of the inequality. Consider the inequality that 3x plus 4 is less than 8. Example 2, let's look at example 2. Find the solutions of the inequality here. It says 7 minus x less than or equal to 9. Solutions. Let's start by moving the 7 to the right hand side by subtracting 7 on both sides. So we are saying 7 minus x in bracket minus 7 less than or equals to 9 minus 7. So we can now say, okay, minus x is less than or equal to 2. How do we get rid of the negative signs in front of the x? Just multiply by minus 1 on both sides of the equations, or change. It will change by saying, okay, less than or equal to greater than or equal to. As you multiply, you will have, you open bracket, minus x close times minus x close times minus 1 close the bracket greater than or equal to 2 times open bracket minus 1 close the bracket. So you have x greater than or equal to minus 2. So solving inequality using inverse operations. When we're using inverse operations, let's take example 1. 10y plus 5 less than 13. So you will now pick 10y plus 5 minus 5 less than or equals to 13 minus 5. So that means we are subtracting 5 from both sides of the equation. So here you will now have, when we say 5 minus 5, it goes. So you will now have 13 minus 5, the answer will be 8. So you have left with 10y less than 8. So you say, okay, 10y over 10. When you divide both sides by 10, 10y over 10 less than 8 over 10. You will have, so 10 cancel 10 will give you only y. which is less than 0.8. I hope this is clear. So example 2, 5 minus 4y less than or equals to 3y minus 7. So well, you say, okay, 5 minus 4y plus 4y less than or equals to 3y minus 7 plus 4y. So that is by adding 4y to both sides of the equation. So if we're adding 4y to both sides of the equations, so let's solve it. We say 5, so 4y plus 4y, it will go. So 4y can cancel. So what we are left with is, okay, 5 less than or equals to 7y minus 7. So we are having now 5 plus 7 less than or equals to 7y. So 5 plus 7 will give you 12, which will now be equal less than or equals to 7y. So divide both sides of the equation now by 7. So if you divide them by 7, what will be left is 12 over 7 less than or equals to 7y over 7. So you will end up having 1.71 less than or equals to y. So y will not give you greater than or equal to 1.71. So application of inequalities to angles. Let's look at how we can apply inequalities to angles. Inequalities are a significant part of geometry when it comes to angles classifications. So we have 3 types of angles, which are the right angles, acute angle, and the obtuse angle. We have 3 types of angle, and we say with the right angles, the acute angles, and the obtuse angle. Right angles is an angle with 90 degrees. An acute angle is an angle from 90 degrees downwards, while an obtuse angle is bounded to 90 to 180 degrees. Using the 3 specified angles above, if we assume y to represent right, acute and obtuse angle independently, we can represent the equations as stated below. 1. If y is equal to 90 degrees, then angle y is a right angle. That is correct. So that also applies by saying if y is less than 90, then angle y is an acute angle, because we have explained them, anything less than 90 degrees downward. Then, and if y is greater than 90 but less than 180, then that angle is an obtuse. You can also believe, because you said obtuse angle is bounded between 90 to 180. Thank you. Let's move forward. So examples of inequalities to angle now. Let's look at the examples, some of the angles. Example 1, identify the angles appropriate for the figures below. So when we say y is equal to 180, abi? So y is equal to 190, or y is equal to 170. Solutions. So remember, any angle below 90 degrees is an acute angle. Thus, y is equal to 80 is less than 90, and thus the angle under the equation is an acute angle. Is that one correct? Fine, thank you. So for y is equal to 90, since an angle is equal to 90 means the angle is a right angle, we have reasonable evidence to conclude that the angle is a right angle. Remember the definition given earlier? So for y is equal to 170, we can say that the angle is question here is an obtuse angle, because an angle above 90 degrees but below 180 degrees, then the successful angle is such angle is an obtuse angle. I hope you are following. So I want to believe you understood this topic of inequalities, and I'm so happy you have listened. See you in our next class. Thank you very much.